What's up, everybody? Calvin here, Network Whiz Kids. I'll give it a few minutes before we start today's knowledge transfer. Just give everybody a chance to join. I'll also share my link on Twitter. For those that are joining new, please feel free to subscribe. Just share this link out. Feel free to share the link with your friends. Follow me on Twitter if you're not already following me. All the links are there on the screen. Alright. There we go. Hey, Tech Tips. I'm good, man. You? Just wait for a few more people to join. Then I can start. For those that can't watch it live, again, as I said before, these videos will be published after on my YouTube channel and also on my blog, so check that out. And for those that have not checked my blog out yet, or maybe have been on my blog, on the top left hand side of the main page you can enter your email address and subscribe, so you can actually stay up to date with all the posts. So as soon as anybody, including myself, makes a post, you'll receive an email. So it might be worth subscribing to that as well. Alright, cool. I'm glad you're looking forward to learning some ASA with me. Hopefully the things that I show and demonstrate become useful for you guys. Oh, nice. Red Hat certified as well. Okay, it's not a certification I've really looked at, but that's interesting. Good to know. Alright, cool. So I think without further ado, I'm going to get started with today's knowledge transfer session. And as you can see from the title, I'm getting started with the Adaptive Security Appliance, aka the ASA, and also the Adaptive Security Device Manager, which is the on-box management, also known as ASDM. This video is, or this KT session is mainly focused on those that are new to maybe the ASA, or studying or starting to study for the CCNA security, and have not really had any hands-on experience with the ASA as of yet. So it's gonna be basic for maybe some people, but for those that are new to the ASA, you might find these basics are actually quite useful. I'll pause in between to answer some questions like I did in the previous episode, and catch up with you guys and answer any questions that you may have. So this is the topology that we're going to be working from today. So again, it's a simple topology. I mean, the main purpose of this is to demonstrate the ASA, which in my case today we're using the virtual ASA. There is a few differences between the virtual to the physical ASA, but that's beyond the scope of today's knowledge transfer. I again have an Ubuntu machine, and I have what you can see on the left there is the internet cloud, and hopefully we can connect to the internet using that internet cloud. So these are the configuration steps. So we're going to start off by giving the interfaces a name and security level, which are quite important. We'll touch on this when we actually start the configuration. We're then going to give the interfaces an IP address and enable them. We're going to allow HTTPS from the inside network, and you'll see why we need to do that in the lab. We're going to configure device local username and password. Again, this is an important step for what we're trying to achieve today. And we're going to configure local authentication for the HTTPS access. And then, last but not least, we're going to configure, well, we're going to actually try to connect from our local machine via SSH to the ASA, and there's a few commands that we need to enter in order to do that. There is one thing that I didn't include, which is quite important to test connectivity using ICMP, and that is to enable inspection of ICMP. By default on the ASA, ICMP inspection is not enabled, so it will not pass ICMP traffic, so you know, it'll just drop it. So we'll take a look at that, and we'll go into that. For those that watched episode 1, you would have known that I had some verification commands or verification steps at the end of the presentation. I've not included that today because I thought as we go through the lab we can, you know, take a look at the verifications and, you know, configurations necessary as we're going through, rather than doing it all at the end. So we'll switch over to the CLI now. I'll just get mine up. And as you can see, we're using the ASAV, the virtual ASA. It's unlicensed at the minute because I'm only using it in the lab environment, which restricts throughput. So that's not really a big problem. ASDM comes installed on the ASAV by default, so you can actually check this by directory boot, and what you can see there. So if you do a dir to a directory, you won't see ASDM in there. Core dump info, this is a dummy file, if you like, dummy folder and file what I created, so I could use my secure CRT. Again, I've done a blog post on this using virtual serial interfaces so check that out on my blog. But then if you do directory boot, you can see that ASDM is installed here. Okay, so going back to the presentation, as I say, our first step is to give the interfaces a name and security level. So at the start I said we'll touch on why that's important, and the reason why it's important with the ASA is because security levels determine what traffic is permitted and not permitted by default, if that makes sense. So we have a security level of 0 to 100. So a security level of 100 is the most trusted, if you like. So an interface with a security level of 100, which is typically going to be your inside network, will have a security level of 100, which will by default permit traffic to lower security level interfaces. A interface of security level 0 is not going to permit traffic without explicitly stating with the ACL. And security levels between 1 and 99, basically you've got access list that will implicit ACLs that will allow to lower security levels but not to higher security levels unless explicitly permitted. Tactic says the text is very small. Could you please make it a bit larger? Yes, let me try and do that now before we move further on. Just give me a second. Let me session. I'm not sure because of what I'm sharing it on if this will make a difference, but we can try. Okay, that's made it slightly bigger. Is that better? Can you see that better? Just let me know if you can see that better in chat, then I'll carry on. Okay, no problem. Right, I'll continue then. That's good, at least you can read it. That's fine. Right, we'll carry on. Okay, so hopefully that clears it up in terms of how security levels work on interfaces. So ideally, looking at our topology at the top of the screen, we can see that we've got an inside network of 192.168.1.0/24. This is going to be our most trusted interface coming off the ASA, so gigabit 00. Then we have the outside network, which, because of the way I've got it set up in GNS3, I'm just going to be getting an IP address via DHCP for that. But this security level will be 0. Typically in environments where you've got DMZs or DMZs, however you pronounce it, you could have a security level of 50, because what you'll be doing is you'll be permitting traffic from DMZ out, and also you'll have ACLs that are permitting traffic to services such as, you know, your web servers, etc. Right, okay, so what we'll do, we'll start by configuring the inside interface. So interface gigabit 00, and we'll give this a name, so you can name it. And inside, now if I name this interface inside, it should automatically assign a security level. So we'll do that now. Oops, I doubt if I did name if, sorry. So name if is for interface inside, and as you can see by default, let me just highlight that, we've got a message telling us that because we've named it inside, the default security level has been set to 100. You can, however, if you didn't want the security level to be 100, you could change this. So to do that, you just simply type security level, and you can see there you can do 0 to 100. So you could change the security. So let's say, for instance, if I've got none lock on, which will help, 95. So if we do show name if, we can see now the interface for gigabit 00 has been changed to 95 now. So I'll just change that back to 100 just to keep things how I want them to be. And what we'll do is we'll jump onto interface gigabit 01, which is going to be acting as the outside interface, and we'll name this interface outside, and we'll see again if the security level is automatically assigned by default, and it is. So as you can see, we've got another message saying basically because we've given it the name outside, by default it's given us a security level of 0. So if I do show name if, we can see that our interface gigabit 01 outside has a security level of 0. So again, if we wanted to change that, we just issue the security level command and change that, but we'll leave that as it is for now. So we've given the interface a name and a security level, as you can see in the topology, and now we're going to assign them IP addresses as per the topology, and then we will enable them by issuing a no shutdown command. So while we're on the outside interface, we'll do IP address DHCP, and like I say, the other reason I'm issuing DHCP on the outside interface is because of the way that this environment on GNS3 is set up. Now I'll issue a no shutdown because the interface is shut down by default, and we'll give it a second to ensure that we actually get an IP address assigned. So it looks like it, yep. So as we can see now, interface gigabit 01 has been assigned an IP address and it's showing us up. So the IP address that's being given is 192.168.222.131, and the method is DHCP. So what we'll do is we'll then manually assign the IP address as per the topology on the inside interface, which is going to be 192.168.1.1/24 subnet mask, and then we'll do a no shutdown because, as you can see currently on that interface, it's administratively down, which is the default method. So we'll issue the no shutdown, and we'll just up arrow a few, and now we can see gigabit 00 has been assigned the IP address that we've given it, and the method is manual and it's up as well. So we've given interfaces an IP address, and we've also enabled them, and we've verified that the interfaces have got an IP address and that they are indeed up. So what we're going to move on to now is allowing HTTPS from the inside network. Now the reason you'd want to do this, and normally you'd have a separate management out-of-band network to do this, but for our demonstration it's not necessary. But the reason you'd want to do this is so that you could access ASDM potentially using HTTPS. So there is no concept of HTTP on the ASA. It's all secure using HTTPS. So what we'll do is we'll enable HTTPS now, and what I meant by there's no concept of just HTTP, I'll show you now. So if I do HTTP, so even though the command is HTTP and not HTTPS, this on the ASA firewall is secure. So there's no concept of HTTP only. So what we're going to do, as I said, we're going to enable HTTP services, HTTPS services on the inside network. So we start with HTTP server, and then we'll do enable. This turns the service on. Then we'll do HTTP, and looking at this command here, hostname, this is what we're going to do next. So the IP address of the host or the network authorized to access the HTTP. So we want to access ASDM via our inside network. So we could lock it down to one host, but we'll lock it down to the network only. So we'll do 192.168.1.0, and then you apply the net mask. So ours is a /24, and then you specify the interface. So we're doing this for the inside interface, and that's it. So now we've enabled HTTPS services on the inside interface. Now I have just had a thought when I've done that, which is that ASDM is not supported on Linux, and in the topology I'm using Ubuntu. So what I'm going to have to do is very quickly I'm going to have to throw in a Windows machine. So I'll do that now, so then we can have a look at ASDM together, because I appreciate that if you are new to Cisco security or the ASA, you might not have actually used, I'll put that there so you can just see it, you might not have actually used or had a chance to access the ASDM. So that's the whole point of trying to do this now. So I'll just start up that machine quickly as well, and while I do that I'll switch that one. Yep, so what I'll do is I'll just get the Windows machine up, which is currently starting. So while we do that, I'll have a look if there's any questions. Sometimes I've seen the ASA placed behind a Cisco router. I don't know in what situations is that preferable. Sorry for asking questions during the session. You don't have to reply to me. No, it's totally fine. Obviously, I'll see your questions when we have mini breaks like this, and I'll do my best to answer them. So it's totally fine. That's what this is all about. Any questions, throw them out there. As you know, silly as you may think that they sound, they're probably not silly, and you know, more than likely somebody else has the same question as well. So any questions you've got, throw them out there. I don't mind answering. So yeah, I mean, it depends on the actual network itself, I would say. You know, ideally you could have a firewall sat on the edge of the network. You could have a router sat in front of that, then the firewall, and then the IPS behind it. You know, it really does depend on the actual design of the network, is what I would say. So I hope that answers your question. Now let me get back to this. Just make this screen a little bit bigger for you. There you go. So I hope you can see that Windows machine, and let me just double check we have an IP address for this. Yep, so I have got an IP address for this. Yeah, 1.10. Okay, cool. So what we can do is, I mean, I already have ASDM installed on this device here, but typically if you didn't have ASDM installed, what we would need to do is we would access, let's use Explorer, it might be slightly faster and less resource intensive. Yeah, okay. Oopsie. Not that one. Right, so what we would do is you would put in the, I'll just make that a little bit bigger actually, because you might not be able to see that. If I can zoom in on that one. Yeah, so hopefully you can see that now. So what I would do in this case is, because we have enabled HTTPS services on the inside of the network, we'd simply open a browser, HTTPS, and then we would enter the IP address of that interface, which in our case is 192.168.1.1. And obviously, because we don't have a certificate for this device, we're just going to click continue and continue through because we know what it is. And you do need, this is a Java based application, so you do need Java to actually run ASDM if you've not got ASDM Java installed before you can run ASDM. So what we do in this case, I'm not going to do this because, like I said, I've already got ASDM installed. You would install Java first, verify the Java install, and then you would install ASDM. Then once you've installed ASDM, you would obviously open it up, as I'm about to do now. And it's opening up in the back here. And this is what it looks like. Let's see if I can, yeah, I can't make that bigger, unfortunately, but this is what it looks like. So device IP we put in there, and in our case we currently don't have any username or password set, so we're just going to click OK, and then we'll continue through even though it's saying our certificate's not valid. We know the reason why. And as you can see now, it's going to start loading up. What it does as well, it checks for software updates as well before actually opening ASDM. So there we go. I'm prompted with a lovely licensing issue because I've obviously not got it licensed, and it'll load up. I'll just make this a little bit bigger. Yep, login history. And there you have it. So now you've got ASDM open. On the main screen you can see that it's telling you ASA version, the ASDM version, the mode that the firewall is running in. So obviously there's two modes with the ASA rooted and transparent. Ours is running in rooted. Tells you the flash, memory, the uptime, everything. And obviously a lot more you can do on ASDM as well, which I'll give you a little breakdown and show you what's what. The reason I wanted to show especially the beginners how to access ASDM and how to do the basic configurations is because when you first start out with using the ASA, it can be a little bit daunting. It is a very or it can be a very sophisticated device in terms of configurations, so it's always a good opportunity to learn with the ASDM, using the GUI based and creating access rules, etc., just to start to understand how things work with the ASA. And you can also, before you actually push configurations using the GUI ASDM, you can actually view the command output with a setting. Let me just see if I can find it. Yeah, that might be a little bit small, but hopefully you can see it, but I'll read it out. Yeah, so communications, here you've got a little tick box that says preview commands before sending them to device. So you can make your configurations on the GUI, and before you press apply, send, or save your configurations, it'll give you a nice little output of the actual configuration that you would enter on the CLI before you push it. So it's a good way to actually learn the commands and to try and understand the way that the ASA works. It really helped me when I was first starting out. I do know that it's included, or at least in my CCNA security, which is still on the same version, I believe. It was included in the content that you study, so the CCNA security material. So it's really good if you can get all the GNS3 and ASAV unlicensed. You can start to play with ASDM as well, and fully familiarize yourself with it. I mean, fast forward a couple of years now, I am not really a big fan anymore of ASDM. I prefer to just use the command line because I've got used to just using the CLI, obviously on production networks, etc. So moving back to our presentation, so we've allowed HTTPS now from the inside network, and we've just verified that by actually connecting from our inside Windows machine to ASDM, and we've actually, we're on the device now via ASDM. Now we're going to configure a local username and password, and these two next steps here, configure local authentication for HTTP access, these are going to be used together. So basically we can authenticate via our local username and password. So as you remember, with when we accessed ASDM, we didn't need a username or password, and because we'd not set one, it's blank. So now we're going to actually need to authenticate using a username and password, which we're going to have locally on the ASA in order to access this. So what I'll do is I will exit out of this. So then when we open it again, we'll have to re-authenticate. And what we'll do now is we'll move back to the CLI. But just check that. So yeah, local username, password, and authentication. So we'll move back to the CLI now. And what we're going to do is we'll create username. Normally in production environments, or on live networks, or when you're deploying in a live network, more than likely the customer is going to have a remote authentication server, such as maybe ICE, Cisco ICE, to authenticate. So there is a few more configurations that we would need to do, but for this demonstration today we don't need to do that. So we're going to call this WizKid, and we're going to give it a password of Cisco, just to keep things simple. And then, as I said, we need to now authenticate. We want anybody on that inside network accessing ASDM, we want them to authenticate against, in our case, our local user database. So to do that, we'll do AAA authentication, and as you can see, we have a bunch of options we can use. So we're going to need SSH, because we're going to try and access the ASA from the workstation using SSH as well, and we're going to need to do HTTP here. So we'll do HTTP first, and then console. And as I was saying, normally you'd have a remote authentication server. So if you did, you would specify a name here, so a name that you create. In our case, we're only going to specify local. But let's say, for instance, we're specifying a remote server. We would say, let's say, server. And if we wanted to, let's say, in a scenario where there were a potential for that server to fail, and we didn't want to disrupt access or our engineers from getting access to this device, we would typically have one or two fallback emergency break the glass kind of thing users configured locally. So what we'd need to do is we'd need to have local at the end of this configuration here. So basically what this is telling us is that it's going to first try the server, then it's going to try and do fallback to local authentication after. And it says there, if all servers in the server group have been deactivated, authentication will be done against a local database. So again, in our case, we're just going to do local, and then we'll do AAA authentication SSH local, and we also need to do AAA authentication, and we'll do enable. And let's just go back a minute so I can show you. So enable is so that we can get past the enable prompt, so we can get into global configuration. We need to have this configured. In fact, what I'll do, just to prove that this won't work, is I won't actually enter this command yet. We'll leave that command for now. So we've created our user. So we'll do show run. So we can see our Michael, the password has been hashed. So you can't see the password. Our username is there. So now if we flip back to our Windows machine, get rid of that. What we're going to do now is we'll jump back onto ASDM and we'll try authenticate without a username and password like we did the first time, and we'll see what happens. Continue through, and as you can see now, it's saying that authentication is, you might have to put on your glasses maybe if you can't see that, but what it's saying now is authentication is required. Please enter your username and password. So we'll go ahead now and we'll enter WizKid, and our password was Cisco, wasn't it? We didn't do a capital, did we? I don't think we did. We'll try it anyway. And yeah, as you can see there now, it's just loading the cache software, and because our credentials are being checked against our local database, we've now been given access to ASDM. So without those local username credentials, you will not be able to access ASDM now. Okay, so it tells you login history, etc., which is cool. So what we'll do now as well, because we have done it for SSH, we'll connect to the firewall on port 22 SSH. And I don't think that's gonna be, in fact that's not working, so I may have missed something. Let me just double check. Yep, I have. So I need to, again, the same way we did enabled SSA HTTPS services for the inside network, we need to do that. So we'll do SSH version 2 to start with, and you'll see that there's, if I do a question mark there, we've got two versions, version 2s. In fact, let me flick back to the CLI, sorry. So yeah, as you can see there, we've got two versions. We'll stick with version 2. And what we're going to do then is SSH from 192.168.1.0 network. And inside. Now if you flick back to our Windows machine, so open putty again, and we'll do 192.168.1.1, and now you can see that we've got access. So again, I'll try authenticate with nobody, and it's going to shut me down. Yep, access denied. So I'll reactivate this session, and then I'll log in as WizKid. In fact, let me make this a little bit bigger just so you can see, hopefully. Change settings. That's the thing with these windows, sometimes they're so small. make it a little bit more bigger, just to be sure that you guys can see it. There we go. So now you can see. So what we'll do is we'll enter the password for WizKid, which was Cisco, and it's not letting us in. Ah, there we go. So now it's letting us in. But as I was saying, because we've not enabled the, so this is all valid, we've got access now to the ASA command line via our workstation, so we don't have to get up and physically plug into the network, into the device. We can sit at our desk now and configure the ASA, or do whatever on the ASA. But you'll find now, because I didn't do the authentication for the enable, it's not going to let us past here. So if I do Cisco, it's not going to let us past. In this case it did, because there's generally the at the start of when the ASA first boots up and there's no configuration, this is what it falls back to. So what we need to do is, because as you can see I entered Cisco and it told me invalid password, so if I do no, I'm not sure. Yeah, so what I need to do is AAA authentication, and we'll do it for enable and local. And you might have noticed every time I'm writing local, in fact, there we go. So yeah, you might have noticed every time that I'm writing local, it's in capitals. And the reason being is because it needs to be in capitals in the ASA. So if I try and write local in lowercase, it's going to tell us that the group server doesn't exist, because it's actually thinking that this is a remote server group. So we actually need to specify local in capitals like that. Now as soon as we do that, let's flip back to the Windows machine. We'll exit out of there and then we'll jump back in 192.168.1.1. Again, I'll just make this session bigger so that you can see. There we go. So we'll log in again with WizKid, and we'll enter Cisco and EN for enable, and again Cisco, and this is where it failed last time. This time hopefully it works. And there we go, we haven't got wrong password, so we're in. We can do, issue all the commands you would on the command line, but we're doing it remotely. So brilliant, we're in. So while we're on here, in fact, we might as well, let's just flip back to the presentation. So we've basically done all them steps now. We've verified that we can access the ASA from our machine. We've got obviously a local authentication with the username WizKid in place. So all these steps are done now. But as I said, there was one step that I didn't include in our configuration steps, and that was to do with ICMP. So what we're going to do is we're going to create a route out to the internet, and what we're also going to do is we're going to do a we're going to enable ICMP inspection. So if I do on the ASA ping, let's do ping So I need default root. So it's so for the ASA, we need to just flick back to that Windows machine, and we'll do it on here. So on the ASA, we've got no root, so show root. So we've got no root currently going outside. We need a default root. So if I do root, it works slightly different to iOS in terms of routers and switches. So we're going to root. So as you can see, we've got the inside and outside interfaces. So we're going to root out 00, which is default. So we need to know the gateway by. So in fact, because I didn't configure that, let me just quickly jump on. We'll flip back to here because I need to open a little cloud device that I've got. In fact, I think it's actually using let me flick back to Windows because you probably see it a little bit better. And what I'll do, in fact, IP brief. So I think we're using, we'll try .1 because it's not actually letting me access that device. So what we'll try to do, one 192.168.222.1. Let's try ping 192.168.222.1. Yep, so we can actually get to that. Let's try ping Google DNS. Maybe it's still not going to allow me outbound, but at least we can ping from there. So what I'll do, don't think we're going to get outbound connectivity, but if I do 192.168.1.1, so I can ping the ASA from the machine. Let's show root. So yeah, I'm sure that is. I'm sure that's the gateway. Well, I'm assuming that's the gateway anyway. So before we carry on, what I'll try to do is, if you guys want to see it, in fact, I know we've configured all the steps in the presentation for today, but if you want to go a little bit further, we can investigate and see if we can actually get out to the internet by looking at some more commands and hopefully testing connectivity that way. What I'll do first is I'll show you where you can apply ICMP inspection. So as you can see, we have we've got policy maps, class maps, and service policies. This is included in your CCNA security exam, so it's best off looking into this. And as you can see, we have a default global policy. Now the global policy is not per interface, it's actually, as it says, it's global, so it applies to all interfaces. So if you have a look on inspection here, we actually not by default inspecting ICMP. So what we want to do is we actually want to inspect ICMP. So to do this quickly, we can just highlight this. Alright. Policy map. Global policy. I'll write it out. Then we'll do class inspection. Yes, class. Where's it gone? I'm going blind. Let's scroll back up to that. Yep, so it's inspection default. Inspection underscore default. And what we're going to do is then we want to inspect ICMP. Like that. So now if we do we'll do ICMP. We can now see that ICMP is being inspected, so it should be permitted outside the network. And before we go on to doing the NAT and stuff, I'll just take a look, see if we've got any questions. So let me just get this back up. There we go. Okay. So I've got a few questions by the looks of it. Let's have a look. So a secret, if you like, is, as I showed you earlier, I'll show you again, is by default it hashes, so you don't need to do username admin pass secret, because look, it's not supported by so basically by default it's gonna hash your password. So if I do show run WizKid, as I did before, we can see that all I issued was username, WizKid and password, then the Cisco, as you can see there, it's been hashed. You can't see it. So the next question, ASDM uses HTTP or SSH for login. So ASDM uses HTTPS for logins. Show how to do NATing. So as I said, I'll do that now. In fact, we'll take a look at some NAT quickly, and some very basic NAT. And does the ASA support EIGRP, OSPF, BGP? Yes is the answer, but I've not been in many situations where I've actually configured dynamic routing protocols on a firewall. Normally they just pass dynamic routing protocols through the ASA. And last question before we go on, would you recommend Checkpoint or Cisco ASA? Your views please. Well, I mean, I work for Cisco, so it probably wouldn't be right me saying I recommend Checkpoint. But no, honestly, I have worked with both vendors. I've worked with, you know, Checkpoint, R7730, I think, were the last version I worked on. In fact, I think I've got a few videos on my YouTube channel with Checkpoint, and obviously I work with you know, ASAs pretty much on a daily basis. And I'm gonna leave it there quite simply because, you know, obviously I work for Cisco. I'm gonna recommend Cisco products, but honestly, the ASA is a proven firewall. It is a really good firewall, which is why it stood the test of time for so long now. And you know, now that we've integrated the ASA code with FXOS to make FTD, you know, it's looking like we're gonna have some good things moving on into the future. So keep watching out for stuff to do with FTD. Hopefully that helps. So what we'll do is we will do some basic NAT inside to outside now, and then we'll finish off the video and answer any questions that you guys may have. I hope you've enjoyed it so far. I hope that for the users or the viewers, sorry, that are new to ASA, I've found it quite useful in terms of how to actually get onto ASDM and how to navigate, you know, doing the basics. So what we'll do now is we'll, on the typical iOS, we'll do show NAT, we'll do show IP NAT translations or statistics. This command doesn't exist here, so we've got show NAT, which obviously we've got no NAT, and we've got show xlate, which is an xlate table, which we'll, you know, hopefully see more of in a bit. So what we'll do is we'll first create an object network, and we need to give this network, so basically an object is it's an object. So let's say we're going to call this one inside. We'll call this inside hosts, and if we question mark, we can do a few stuff here. We can actually NAT on the object, or we can NAT in global. For this session, we're going to do a NAT on the object. So what we need to do is we need to then issue the command subnet, which is for the actual subnet, and we're going to do 192.168.1.0, and then we enter the neck mask as it says. So if we do show run include object, we can now see we've got an object there, and if we do show object, we'll do show run object, we can see that we've got our subnet there as well. So now if we want to NAT that, so we're still within the network object that we've called, where's the name gone, that we've called inside hosts. We're still within that, so what we're going to do is we're going to NAT, and we're going to NAT from inside, and you can see we're going to the outside. So it's just basically saying here, what do you want to NAT? So where's this network? So this network's inside, and we're going to NAT it going to the outside. And we could do source, dynamic, and we could do in fact, what we'll do is we will really quickly, let me see if I can get this up to make it more understanding for you. Just give me a second, let me try and find it real quick. That's primary. see if I can get it up for you. I just want to show you an example of some configuration that I did on another lab, just and explain that maybe it makes more sense. Let's have a look. So we can do right. Let's see if I can get it up. No, I don't think I can find it. Yeah, no, I can't find it. But what I just basically wanted to show you some output. So yeah, as I said, you can do the natting on the ASA on the object itself, or you could do it on the global configuration. So we'll do where were we? Nat inside, outside. And we're gonna do pat. So what we'll do, so we'll do dynamic, and we'll do interface. So that's basically telling us that the NAT that we're doing is port address translation on the outside interface. So if I do show NAT, we now can see that we have one NAT, we've got no translated hits or untranslated hits. If I do show xlet, we've got no translations as of yet. So what I'm going to do is I will create a access list. Going back to iOS there, access list, and we're going to call this inside permit ICMP from object, and our object was called, where has it gone? A bit further down. Our object is called inside host, and we can see going to destination, so destination is going to be any, and we could do, we'll catalog it, but yeah, we'll just go with that. So we'll do access group. So we need to then apply the access list. So we've got to specify the access list name, so access list inside, then it's for traffic coming inbound, and it's on interface inside. So access group inside, in, interface inside. Looks a bit confusing at first, but the more you play with it, the more you get used to it. So that should permit that traffic now. So I don't know if we've still solved the issue with the outbound connectivity. I don't think we have, so I'll just put that on repeat. Let me do, yeah, I don't think we have we? So ideally, let me just quickly have a look and see if I can sort this. Looks like they've changed this actually. Cloud, I don't want to use that. Yeah, it looks like in this version of GNS3 they've actually changed this, because before you could actually access the what I'm calling the internet, and you could check out the IP address. But if I do it's not going to be working, but yeah, but I mean I can ping in fact, let me see, sure, excellent. So in fact, yeah, even though we can't get outside, we can see that, you know, it's the translations trying to occur. We can see that it's an ICMP part address translation from inside, and that's coming on 192.168.1.10, which is our host, and it's going to outside 192.168.222.131. So if we do show interface IP brief, we can see that that's going to the outside interface, and we have a few flags which is beyond the scope of this. So yeah, that's so if we do show on that, we can see as well that we've got 16 translated hits, which is good. We've got no untranslated hits, but obviously our because of the topology in GNS3, it's actually not going out to the internet. Show run access list. So you can see we've got an access list permitting ICMP from inside to any. So you can do show access list as well to see more detail. So you've got, what I've just done there is show run access list will give you an output of just the access list, and if you do a show space access list, you can see what it's doing is giving us a more detailed output. And if you correlate this, so we can see we've got 16 hits on this ACL, and then if you correlate this with moving back up again with the translations, where's it gone? There it is. You can see that we've also got 16 hits. So we know that that configuration's fine. It's just obviously a problem we've got with the what I'm calling the internet device. So going back to that, so that's, I've gone a little bit beyond what I intended to do today, but hopefully you guys have found that useful. I'll plan to do more sessions based on the ASA in regards to access lists and NATing, and maybe a bigger topology where we can actually see, you know, maybe do a main site and a branch site, and then we can see what traffic we can permit across, what traffic, you know, do one-to-one NAT translations, etc. If you guys will find that useful, maybe for the more, you know, advanced viewers that have, you know, maybe got a little bit of ASA knowledge but want a little bit more. I hope that you guys, for the first time viewers or those that have not really yet touched an ASA, I hope that that information that I've given you there helps moving forward and helps you with your studies as well. So I'll just flip back to some questions and we'll end the live stream. So, very informative session. Thank you. I'm glad that you've actually enjoyed it, and thanks for sticking with me throughout, because it has been going on for about an hour now, but I'm glad that you guys, you know, found it useful, and I'm glad that you're looking forward to more videos. Yeah, trace through, I was thinking about that, but I think what the problem is with the actual internet cloud thing that I've got in GNS3. They've changed it. The version that I've got GNS3 is changed from the previous version I was using. Before you could click on it and actually look at the IP addresses, etc. But this is a little bit different now. But not to worry. Yeah, so looking forward to a bit more explanation on that configuration. Yep. So maybe what I should do is a separate session just on NAT configuration alone, because it works differently to you know, normal Cisco iOS, and obviously that for some people can be quite complex and confusing, and the ASA don't make it any easier, because you can do, as I've just shown you, you can do NAT on the objects, and you can also do NAT globally. So if I show quickly on the CLI, we can do, so now we're in global, we could do NAT here as well. So you could do NAT inside, outside, and we could do specify your source. So in our case, our source would be the so we could do static. So our source would be, we could specify the object that we created and then go from there. And like I say, then you can also do NAT on the objects. Show run object, show object, include object. It's not showing on there, but yeah, you can also do NAT, as you can see, on the objects as well. So yeah, thanks for watching, guys. I'll leave it there, and if there's no more questions, I will end this session. Feel free to reach out to me if you've got any more questions or any more questions pop up. Subscribe to my channel if you aren't already, I'd appreciate that. And also my blog, all the links are on the start of this presentation here. And yeah, this will be getting published obviously to YouTube, and I'll also be posting it in on my blog, synac.co.uk. So yeah, thanks for watching, guys. It's been brilliant, enjoyed it. Bye for now.